Now, how do you visually represent a particular function? Now, uh, it's quite a simple task, but it's not as simple as I mean, the meaning is a little more deep and tricky than what meets the eye. Let us look at the case, and of course, a function is we know that a function is generally represented as f of x is equal to y, which simply means x is the input values, and of course y would be the output values. So and we know that all the input values that is would be coming in the domain, and naturally we know that those values which are coming as outputs, that is the all values would be coming in the range. And the interesting part is that range would be coming inside the code domain. So you'd be having the range here, and the whole thing is representing the code domain. Now it's quite simple. X1, suppose an input value of x1 would be giving y1, so it goes on like that. But all the y values would be coming in the area within the core domain, which is meant for range. Now it seems quite simple. So now the key part is that why is the range coming inside the core domain? What exactly does it mean? Now let us look at a simple case to prove the point. We know that let us look at the square function, as f of x is equal to x squared. And we simply know that x is an independent variable. If we are dealing with a set, a function from between the set of integers, it simply means that any integer, positive or negative integer, can be input as x. Now it simply means that you have the x values, you have the y values. Suppose, okay, you are taking 2, you'll be getting 4. What does it mean? Now it simply means that what if now we know that as far as sets are concerned, sets of countable numbers are concerned, we are dealing with countable infinite sets. That is, they are countable but they are infinite, which simply means that suppose here x1 is equal to 2, then okay, you'll be getting y1 is equal to 4. Naturally, x2, if I am denoting is it has 3, y2 naturally would be 9. Now going on like that, what about x alpha? Now x alpha, the point here is that alpha is a mathematical concept. It actually doesn't represent any particular number, in the sense that if there is alpha, which simply means that if a countable number can be called, if a particular number is an infinite number, there would be the interesting part that there would be alpha plus. It simply means that if alpha plus 1 is input here, you would be getting y alpha as the output. Now the point which I already mentioned at the beginning of this video is the domain already contains all the input values. So that's a point. So domain already contains domain already contains all the input values, which simply means that all the y or x values, but only the a specific output values are present in, that is the y values are present in the range. It simply means that simply means that you have to input x to get y, or in this particular case you have to input x alpha to get y alpha, which simply means that domain already contains uh, uh, x sorry domain already contains x alpha plus 1, but only if I input x alpha plus 1 I will be getting y alpha plus 1. So it simply means that domain contains all the probable elements, all the probable uh, input values, but range only contains those values which are already input. So it comes to the key conclusion that so the diagram would be something like this. So this is the domain, and here you have the range coming inside the codomain, which simply means that if I denote range as R, then R would always be subset of codomain. Suppose I denote codomain at COD, then the range would always be a subset of the codomain. It simply means that for x1 you'd be getting y1, going on like that. For x alpha there will be y alpha. Not that y alpha is coming again in the space for range, but x alpha plus 1 is also present here, but I haven't input here, which simply means that there are elements here. So it simply means that a codomain has probable elements which can come inside the range only if it's in its input or the process or the function or the input has been already done and to get the particular output. So that's the point, and that is exactly why the visual representation of a function is as drawn here. Thank you.